Okay, this says what's the value of x that makes this equation true, so solve for x. First I want to get common denominator, so I'm going to multiply the numerator and denominator of this fraction by 2. So multiply the top by 2 and the bottom by 2. We've got to remember though here we're multiplying the entire top by 2, so that's going to distribute to both terms. So we get 2x minus 4 over 6 plus 1/6 minus 5/6. Now I'm going to combine this fraction and this fraction. So 2x minus 4 plus 1 gives me 2x minus 3 all over the denominator 6. Now I got a couple options here. I could cross multiply here like a proportion, or I could, since the denominators are the exact same, I could just multiply this side by 6 as well as the right side by 6. That's going to cancel the denominators here and here, which I did. I get 2x minus 3 equals 5. Now just add 3 to both sides. I get 2x equals 8 divided by 2, and I get x equals 4. So that's your answer, and that's choice 1. Okay? Now, 23. I can almost, I didn't, this was an August exam, so I didn't grade this, but I can almost guarantee you that this was one of the most missed questions on the test. Because I think there's a lot going on here, a little bit. Anyway. You've got a function h of t is equal to negative 16 t squared plus 144. It represents the height, so the output's the height in feet of an object from the ground t seconds after it's dropped. So the t is how many seconds have passed since it's dropped. Okay, so the inputs, the domain values, are the number of seconds after the ball has dropped. Okay, it wants to know what's a realistic domain. So it's talking about the context. Clearly here, since t is the number of seconds after it's dropped, we're not talking about any t values that are negative. You know, after you drop the ball, you're never going to consider like, oh, what happened -2 seconds after I dropped it? That doesn't make any sense. So all real numbers just doesn't make sense for the domain. We're not considering negative inputs, let alone, right. So we'll keep it there. All reals, no. Also this one, we're not interested in what happened -3 seconds after it was dropped. That simply doesn't make any sense. So we're talking about, are we interested in the t values from 0 seconds after it was dropped to 3 seconds after it was dropped? That seems like it might be reasonable. And the other one here is, this can't even be a domain. This is a range. This is output values. But so why is it 0 to 3? So this is the answer, 0 to 3. If I graph the function, I get this when I put it in my calculator. It doesn't show everything, and that's because I don't have the window range. This graph is going to simply look like the normal parabola, but it's going to open downward, be really narrow, and then get raised to 144. So I'm going to change my window setting to go to a y max of, let's say, 150. Maybe we'll have it count by tens just so it doesn't look weird, and I'm going to graph it again. So there's the function. Now, think about this. We're not interested in these values. We're not interested in this. The ball did not shoot upwards and then come back down, because these are the negative time values. We're looking at the t seconds after it was dropped. So 0 seconds after it was dropped, the ball was here. So it must have been dropped off of a high place and let fall. Okay? So we're only interested in the domain values from 0 to when it hit the ground, and it looks like it hit the ground at 3. So there's the domain we're looking for. We're interested in the times from 0 to 3 because that's the only time that really models what this problem is about, the ball falling. So that's the answer, choice 2.